Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 4, Quiz 2 Extra Practice Solutions. This is a code breaker sort of extra practice. There's a puzzle that goes with this. Let's take a look at that. So here's the code breaker puzzle. The idea here is that we have a whole bunch of questions on the following page here, all these different questions. There's a total of 15 of them, and we have to do all these questions, figure out the answer, and then we have to find the answer over here in this answer column. And you'll notice that these are written in numerical order, so you can find them pretty easy, just going from smallest to biggest here. So whenever you find the answer, whatever letter's next to that, you're going to put that letter above the problem number in these blanks here. So if you do problem number 1 and you figure out that the answer is 1.5, you would put a W above all the ones that are out here. Now it looks like there's only one 1 out here, but a lot of these there's multiple of the numbers, so you have to be on the lookout for that. And then there's a little hint to help you solve this. Who loves the subscript part of logarithms and why? So let's go ahead, try this out. And oh, by the way, the other important thing. Once you get all the blanks filled in, you're not done. You're still going to have to unscramble each of them to solve this with your mystery phrase. So let's get going on this and give it a try. For our opening problem, we have log base 2 of n squared minus 2n equals 3. So because I have a log equation and I've got the log all by itself here, I can start this one by raising the base, which is 2, to both sides. That cancels out the log on the left side, leaving me with n squared minus 2n, and then I have 2 to the third power on the right side. Next up, that's actually 8, and then I'll subtract the 8 to get it over to the left side so that I can factor this since it's a quadratic. So I need factors of negative 8 that add up to negative 2. 1 and 8 doesn't work. 2 and 4 works if I have positive 2 and negative 4. So let me write n plus 2, n minus 4 equals 0. And then setting each of these equal to 0 and solving, we have n equals negative 2 and positive 4. Now I do need to go back and plug these into the original and make sure I'm not taking the log of a negative or 0. If I plug negative 2 in up here, that would give me 4 plus 4, because a negative times a negative is positive. So that's 8, so that's okay, that's fine. And then if I plug 4 in, I've got 4 squared, so 16 minus 2 times 4 minus 8. That also gives me a positive. So both of these are good answers. And then let me find that down here. Negative 2 and comma 4, that's going to be a C going in spot 1. So that is right here, just one of those. For number 2, we have a bunch of logs going on here. So let me combine all my logs on my left side into one big log. Since I am subtracting these, I can divide the things inside. So this is really log base 3 of x over 5 equals log base 3 of 6. And then since I have a log on each side, let me just raise 3 to both sides. That gets rid of both logs, leaving me with x over 5 equals 6. And then if I multiply both sides by 5, I've got x equals 30. So let me find 30. That's right there. That's an n. So I'm putting n in the 2 spot. We got a 2 right there. And let's just scan the rest of these. There's another 2. And let's see, any more 2's here? That looks like it. So on to the next. For number 3, let me start by popping in this 2 into the log here so I can prepare to get these logs together. So that's going to be 8 squared in there. And now since I'm subtracting these, I can combine them into one log by dividing the things inside. So this 8 squared, or 64 I can write that as, I'll have 64 over 2x inside log base 4. Still have that 3 over on the right side. And now since I've got it down to just one log, let me raise 4 to both sides, the base. So that cancels out the log on the left. I've got 64 over 2x there. And then on the right I have 4 to the third. Now that's really 64 over there. Next, I need to get my x out of the denominator. So I'm going to multiply 2x over to this side, and I'm immediately going to divide 64 back to this other side. Because if I do that, I see that 64 over 64 is really just 1. And then if I divide both sides by 2, I get x equals 1/2. So there's definitely other ways I could have done that. But hey, why not? This worked out. So we've got 1/2 or 0.5 I'm looking for. That's right there. That goes with letter A. So wherever I see a 3 over here, I'm going to put an A above that spot. So there's an A right here. There's an A right here as well, and an A down here. So that's a lot so far. Scanning a little further, we've got another A here, another A here. Are there any more? There's one more down here. So we got a lot of mileage out of that one problem. For number 4, I've got 5 to the 4x minus 2 equals 120. Now, one way I could start this problem, I can't use common bases because 120 is not a power of 5, not an easy one anyway. I can take the log of both sides to pop this stuff out of the exponent. However, before I do that, I actually want to rewrite this because I don't really feel like messing around with all this stuff after I get it out of exponent land. So I can rewrite this by splitting this up into 2 bases. Since I'm subtracting 2 from 4x, I can really divide 5 to the 4x by 5 squared. So if I write this as 5 to the 4x over 5 squared, that's equivalent to what we started with. And if you don't believe me, I mean, if we divide bases, we're just subtracting the exponents, right? So we can get back to where we started if we really wanted to. Now the reason I did this is because I can turn around and multiply both sides by 5 squared to get rid of that. So this is 120 times 5 squared. I'm not really sure what that is. Let me look that up on the calculator. So 25 times 120 comes out to 3,000. So I have 5 to the 4x equals 3,000. At this point, I don't really have much of a choice. I'm going to have to go and take the log of both sides to get this x out of the exponent. So on the left side, I'll have 4x log 5. And I have to take the log of both sides, so I also have log of 3,000. To get x by itself, I'm going to divide by the 4 and the log 5. So that's going to be log 3,000 over 4 log 5. And let me go back to the calculator for this. Now to do this on the calculator, just so I don't have to worry about PEMDAS kind of stuff with this denominator, I'm going to do alpha y equals and get fancy fraction mode here. So I'll have log of 3,000 divided by 4 log of 5. And close the parentheses, and that all comes out to about 1.2437. They wanted 4 decimal places here. So there we go. Now, if you didn't use fancy fraction mode, you would need a parentheses around the 4 and the log 5 to make sure the multiplication all happened at once before you did the division. But fancy fraction mode kind of lets us avoid that. So anyway, this looks like it's going to be m right here. So let me put an m in 4. And are there any other 4s lurking around here? I don't see any, so on to the next. For this one, I'm going to start by getting this x plus 4 out of exponent land by taking the log of both sides. So I'm going to have x plus 4 log of 2.4 and log of 30. Notice that I put my x plus 4 in parentheses just so I don't lose anything there. So next up, to get x by itself, it would be a good idea to maybe divide by this log of 2.4. And if I do that, I've just got this x plus 4 now on the left side. Let me go ahead and also subtract 4 from both sides. Notice I haven't actually crunched any numbers on the calculator yet. I'm waiting until the very end so that I don't lose any accuracy by rounding off too soon. But now it is time to use the calculator. So here we go on the calculator. Log of that stuff minus 4 all comes out to about negative 0.11 if I round that off. A few more decimal places though. This is going to be 499. Let's round this off to 0.1150. That'll do it. And that matches L right here. So that is going in spot 5. Not many 5s in the early going. We get a 5 right here though. And another 5. And any other 5s? I don't see any, so I think that bell means it's time to move on to the next problem. For number 6, I have all these ln natural logs going on. Let me get just one of those on the left side by combining these together. Since we have subtraction of logs, we can make that division of the insides. So ln of 2x over 18 equals ln of 24. And I can now get rid of the ln's on each side because I'm basically raising e to both sides. When I do that, I'm also going to reduce this 2x over 18 to x over 9, because that'll make it a lot easier to do my next step, which is going to be just multiply both sides by 9 to get x by itself. So 9 times 24, let me do that. Just to be on the safe side, I'll plug that in my calculator. Gives me 216. So 216, that's right over here. That's going to be an S going in spot 6. So we've got an S right here, another S here, another S down here, and anything else? Oh, one more right there. For this one, I have e to the 4x equals 9. To get this 4x out of exponent land, I want to take the log of both sides. However, since this is e, I actually want to take the natural log of both sides. Because when I pop that exponent out and have 4x times ln of e is just 1. So that actually works out very nicely if I use ln instead of normal log. So we'll have 4x equaling, and I have to do the ln of 9 as well, just to be consistent. Now I'll divide both sides by 4. So we have x equals ln of 9 over 4. Let me run that on the calculator. So there we go, ln of 9 over 4 comes out to about 0.5493. And that's going to match up with O, so we have to put that in spot 7. So there's an O, and no more 7s on the next row. Nope, nope, nope. Oh, wait, there's one. There's an O, and I think that's it. For number 8, let me begin by combining the logs on the left side using division of the inside thing, since I'm subtracting the logs. So I'll call this just log base 5 of 18 over x minus 6 on the left side. And now I can raise 5 to both sides to get rid of those log base 5s. So we just end up with 18 over x minus 6 equals 9. Next up, normally I would just multiply x minus 6 to the other side and distribute, but I actually see a way I can make my life a lot easier on this problem. So I am going to multiply x minus 6 over here, but at the same time I'm also going to divide by 9 to get the 9 under the 18. So essentially switching the x minus 6 and the 9 from numerator to denominator. And the reason I did that, you might see it here, 18 over 9 is just 2, so that's real nice. And then just add 6 to the other side, we have x equals 8. And just double checking, if I plug 8 back in here, I'm not taking the log of a negative, so I'm good there. So 8, that is g, and g is going in spot 8 up here. And where else do I see an 8? Any other 8s here? Nope, that's it. For number 9, we've got 5 to the 3x equals 106. I'm just going to start by taking the log of both sides to get that 3x out of exponent land. So that's going to be 3x log of 5 equals log of 106. And now I'll have to divide everything by a 3 and also a log 5 to get x by itself. So we have log of 106 over 3 log 5. Let me use the calculator for this piece. So there's what I entered in my calculator using fancy fraction mode. If you don't use fancy fraction mode, you're going to want a parentheses around your 3 log 5 to make that all happen in the denominator. Otherwise, PEMDAS is going to mess you up. So that comes out to about 0.9659. And 0.9659, that's right there, that's u. So we got a u going in spot 9. So there's a u right there. Any other u's? We got one right there. And I think that's it. For number 10, we have a log base 7 on each side, and that's it. So I can actually start by raising 7 to both sides to get rid of those logs. So we end up with 2x minus 3 equals x plus 4. And let me just get all the x's on one side, numbers on the other. 2x minus x gives me an x on the left side. And if I add 3 over here, I've got 7. And hey, the equation has been solved, 7. If I plug that back in, I'm not going to be taking the log of a negative or 0, so that's good to go. So 7 is I. That's going in spot 10. So we have an I going right here. And there's another one right here next to the S. Any other 10s floating around? Nope, I got them all. For this next one, before I raise e to both sides to get rid of the ln, I need to add this 5 over here. So that's going to be ln of x plus 3 equals 3. Now I'll raise e to both sides. That cancels out ln on the left, leaving me with just x plus 3 over there. And on the right, I now have e to the 3. To get x by itself, I'll subtract 3 from both sides. And let me just put that in my calculator to get the exact value, or at least a decimal approximation. So on the calculator, to do e to a power, I'm just going to do second ln, and I'll put a 3 in there. Arrow over to get out of exponent land, subtract 3. That's going to be 17.0855. And that's right here, kind of hard to miss. That's an r. So we got an r going in the 11 right here, and also right here. Any other 11s? Nope. On to number 12. Still got a lot of blanks left over, so let's hope this next one knocks a few of them out. I have 2 logs on the left. Let me combine that into 1 log. Since I'm adding the logs, I'm going to use multiplication of the 2x and the 3x to make this happen. So we'll have log base 7 of 6x squared. Now that I have a single log on each side, I'll raise 7 to both sides, leaving me with just 6x squared and 24. And now it's just basic algebra. Divide both sides by 6. That's going to be x squared equals 4. Square root both sides. I end up with a positive and a negative 2. I'm going to keep the positive 2, but the negative, if I plug negative 2 in here, that's going to make the original undefined. You'd be taking the log of a negative. So since negative 2 makes it undefined, only positive 2 is my answer. And that is right here. That's going to be a b. So we got a b going in 12, right, where's the first 12? Right there. We've got another 12 right here at the end of this word, and a final 12 down here at the very end of the last word. Alrighty, let's try our hand at lucky number 13. Since I have a single log on the left, I'll start by raising 2 to both sides to get rid of that log base 2. That leaves me with a 3x minus 8 on the left, and a 2 to the 6 on the right. 2 to the 6 is 64. Add an 8 over there, that's going to be 72. And 3 divided into that gives me, let me see, I think 24. 24. There we go. So 24. If I plug that in, I'm not taking the log of a negative, so that's good. 24 corresponds with e right there. So we have an e going here for 13. And we've got a lot of 13s. Here's another e, another e, another e down here in the 4th row. And we have 2 more right there. Okay, I think we're done with the e's now. For this one, immediately I can just take the log of both sides to pop that x out of exponent land. So we have x log 6 equals log of 38. And then just divide both sides by log of 6 and use the calculator. So on my calculator, that comes out to about 2.0302. And that's going to be right here. That's an h going in spot 14, so right there. Any other 14s? Yep, we got one right there, and there's another one right there. Finally, down to the final boss battle. We have 2 logs on the left. Let's combine those by multiplying the x and the 6, so log base 2 of 6x. And then I'm going to just raise 2 to both sides to get rid of those logs, so we have 6x equals 18. And divide by 6, x equals 3. That actually wasn't so bad. Plugging that back in, not taking the log of a negative, that's good. So 3, there it is, t. That's my missing letter. So we have a t going there, a t going right there, and a final t right there. And at this point, we've filled in all the blanks. It's time to try to solve the riddle. Who loves the subscript part of logarithms and why? Okay, so we have to unscramble the letters here to form a sentence. So this first one, they're saying who. So I assume that at least this first thing is a name. Let's see, I don't know too many G names. A-G, hold on a sec. M-E-G, that would be like a Meg. So maybe this is Megan. M-E-G-H-A-N, maybe a weird spelling of Megan. Okay, fine. And then this next one, Nartior. I don't know any Megan Nartiors. However, there was a singer back in the day, T-R-A-I-N-O-R. Meghan Trainor is a singer. So maybe Megan Trainor loves the subscript part of logarithms. Now, why would this be? This word is almost kind of ready for us. Because, and then SHE would give us she. SI is not a word in English. IS is. And then ALL would be a word, all. Utabu. Now, how about about? About, we can get out of that. About, this is just the backwards. Let's make it forwards. And the subscript part is the base of a logarithm, so I think BASE makes sense there. So Megan Trainor, because she is all about the base. There we go. Till next time, Mr. Sutton, logging off.